today's lesson is coming from chapter 5, lesson 1 in our book. It's on prime factorization. So let's go ahead and get started here. We've got some vocabulary to review. We know that a prime number is a number whose only factors are 1 in itself. We learned that during the factor game that we played. These were the ones that were considered a good first move because there aren't any factors that your opponent was going to get points from. So examples would be 3, 11, 29, and several others. A composite number is a number that has more than 2 factors. Example, 12, 1,000, 30. These were the ones that were the worst first moves. In fact, some of them, the factors added up to more than the number itself when we were playing the factor game. If we say something is divisible, it just means that when you divide it, there's not going to be any remainder left. A factor tree is what we're going to be working on today. It's used to break down a number into its prime factorization. And the prime factorization is just when you take a whole number and write it as a product of its prime factors. So when we do a factor tree, the bottom row of that factor tree is what's considered the prime factorization. We're going to quickly review the rules of divisibility again. We know that a number is divisible by 2 if it's an even number. It's divisible by 3 if when we add up all the digits, it's divisible by 3. We know that something is divisible by 5 if it ends with a 5 or a 0. 6, the number has to be divisible by both 2 and 3. For 9, again, we're going to add up the digits, and if that number is divisible by 9, the whole thing is divisible by 9. And for 10, the number has to end in 0. So now that we've done that, let's jump right in. We're going to be talking about a factor tree. And factor trees help us to break down large numbers that we're not very familiar with. I don't know about you, but I'm not overly familiar with the number 528. But I know using my rules of divisibility in a factor tree that I can break it down into more familiar numbers to me to get that prime factorization. So what this means is we've got 2 little twigs here. We need to break it down into 2 factors. Well, I don't know much about 528, but I do know that this is an even number, so I'm going to be able to take 2 times something to get it. Well, if I were to take 528 and cut it in half, half of just the 500 is 250, and half of 28 is 14. So if I do 250 plus 14, I get 264. A slightly smaller number, still a bigger number that I'm not real familiar with, but I can work with that. The first thing I need to do here is look at those 2 factors and decide, are they composite or are they prime? Well, I know the only way to get 2 is to take 2 times 1, which means it is a prime number. Whenever we come across a prime number, we circle it and we're done. That's a dead end. You can't go any further. If it's a composite number, which I know this one is because it's still a big number, and if nothing else, it's divisible by 2 because it's even. So we got to add legs to the ones that are composite. So again, 264 I'm not super familiar with, so I'm going to divide it by 2. So 2 will be one of the factors. And when I cut it in half, again, I'm going to do the same thing. I'm going to separate it into 264. So half of 200 is 100. Half of 64 is 32. So I know that 132 is one of the factors. So again, do I have a prime numbers or composite numbers? The first one, I know that 2 is a prime number, so I'm going to circle it. That's a dead end. But 132, I know again I can at least divide it by 2, which means it has more than just 1 as its factor. So I'm going to cut it in half again. Again, I'm going to divide it by 2, which makes 2 one of its factors. And again, I'm going to cut it, break it down into 100 and 32. So half of 100 is 50. Half of 32 is 16. So now 50 plus 16 gives me 66 as my answer. So again, I've got 2 as a prime number, so I'm going to circle that. It's a dead end. And 66, now we're finally getting into some familiar territory. I know that that's composite. It's a double number, so I know that 11 is one of its factors. 11 times 6 are going to be my 2 options here. And so now I don't have a 2 anymore, so I have to check and see, are they prime? Is 6 a prime number? Nope, that one is got more than one factor. But 11, that's another dead end, so I'm going to circle that one. So now back to 6. If it's composite, it gets those legs again. How do I get the number 6? By taking 2 times 3. So I'm going to put a 2 here and a 3 here. When I evaluate them to see if they're prime, I know that a 2 is prime, and I also know that 3 is prime. I'm stuck at all dead ends, so now it's time for me to write out my prime factorization. The prime factorization is simply when we take all of these dead ends and string them together using multiplication. So we typically go with smallest to biggest when we list them. So we're going to start with 2's, and here's where I caution you, cross them off as you go, so you make sure that everyone is accounted for. So here we go. I have a 2 right here. I have another 2 here, so I'm going to write it again. Here comes a third one. And I have one more 2 that I need to add to my list. Now I'm done with the 2, so I move up to the next number, which is a 3. I can cross it off. And last but not least, I have 11. So now the prime factorization for 528 is 2 times 2 times 2 times 2 times 3 times 11. And you can always check your answer by taking out a calculator and plugging this 2 times 2 times 2 times 2 times 3 times 11 in, and your answer should be 528. Let's try it again with a little bit more familiar numbers. We've got 42. 42 should ring a few bells for you. For me, I know that it's an even number, so I'm going to put a 2 here. 2 times 21 is 42. I know that 2 is a prime number, so that's a dead end. But 21 is still composite because I know 21 is the same thing as 3 times 7. So when I look at that, I know that 3 is a prime number and 7 is a prime number. So I'm at all dead ends. Now I'm going to write it out. I have my prime factorization is 2 times 3 times 7. I got a 2 and a 3 and a 7. Now the great thing about prime factorization is that you can take different routes in order to get there. Some of you, I'm guessing, had 42 to start with, and you probably jumped right to 6 times 7. That'll work. We look at it, we know that 7 is a prime number, but 6 is not. So we go 2 times 3 here, and voila, we're at a 2, a 3, and a 7. Just like we were over here, we get the same thing. So no matter what factors, what route you take, as long as your math is correct, you'll end up with the same exact prime factorization. So the prime factorization for 42 is 2 times 3 times 7. Let's try it one more time. 180. Ooh, using my rules of divisibility, I know when anything ends in a 0 that I can automatically divide it by 10. So 10 is going to be one of my factors. 10 times 18 will give me 180. So I'm going to, oh, whoops, I've got a little overzealous there. 18 times 10 is what I want. Are either of those a prime number? Nope, they're both composite. So that means I'm going to add legs to both of them. What are the factors of 10? Well, 2 times 5 equals 10. So I'm going to put those two numbers down, 2 and 5. And then 18, I can get 18 by taking 2 times 9. So So I'm going to put 2 on this leg and a 9 over here on this leg. Now I need to ask, are they composite or are they prime numbers? Well, I know 2 is a prime number. What about 5? Yeah, the only way to get 5 is to take 1 times 5, so that means it's a prime number. 2 again. What about 9? Is that a prime number? No, I can take 3 times 3 to get it. So I'm going to add those legs and put the 3's on there. Now I reevaluate, and 3's are both prime numbers, so I'm at all dead ends right now. So now, starting with the smallest number, I've got a 2 and another 2, so I'm going to put 2 2's down here. I've got 2 3's that I'm going to add to my string. And last but not least, I have a 5. So 2 times 2 times 3 times 3 times 5 is the prime factorization for 180. Now here are 2 that I would like you to do on your own. Put them in your notes. You're using factor trees to find the prime factorization of these numbers, 475, and then do it again for 1,218. See you tomorrow.